What's up guys, Onmaths here, and today we're looking at polygons. We'll start with the AQA, and this is the practice mock paper, because I couldn't find a decent question in the last 4 exams that they've released. So, we've got a polygon here. It doesn't name it, although it's got 5 sides, so it's a pentagon. And they've chopped it up into triangles, and it's asked us to work out the sum of the interior angles. Now, if we just look at one of the triangles, we know the sum of that triangle there will be 180, because all angles in a triangle add up to 180. Then, if I work out this triangle here, we know those add up to 180 degrees. And finally, this triangle here adds up to 180 degrees. Now, can you see that all of the angles in this polygon have been counted, and they've added up to 3 lots of 180 degrees. So all we need to do is 3 times 180. This is a calculator paper, so get my calculator out. 3 times 180 is 540. So my answer to this is 540 degrees. Now this is actually the proof of how we, or the method of how we work out the interior angles of any polygon. So moving on to Edexcel, and their question's less generous. It's just saying, right, we're going to tell you it's a pentagon, but we're not going to tell you how to work out the interior angles, and we've got another issue in there as well. So we're going to have to deal with a couple of things. So first thing we need to work out is the sum of interior angles. Now you might notice it is also a pentagon, but we still need to show our working. Now there's a little trick here with this, and so we're going to work out the sum of interior angles, and the trick is this little formula. So if we start off with the number of sides, okay, and we take away, I don't know what I'm doing up there, move this down. So used to work out an individual angle, but we're not going to do that on this one. Okay, so if we start off with the number of sides and we take away 2, that will show us how many triangles it is. Remember on the last question there were 3 triangles. Well, there's 5 sides in a pentagon, take away 2, and that gives us 3. Then what did we do? Well, we times it by 180. So we times that by 180. So let's do that. 5 take away 2, we're times by 180. 5 take away 2 is 3 times 180, and we know that that's going to be 540. Okay, so that's the sum of the interior angles. We need to kind of understand the second part. So we need to understand where angle BCD is, and we also need to work out where angle ABC is. So BCD, that's basically the angle at C. Okay, so you put your finger at B, and move it to C, and then move it to D. It's a really bad way of doing that. There we go. Move it to C, and move it to D, and it's the angle that's created, so it's this one here. Same with ABC. Move your finger to A, then move to B, and then move to C. It's that angle that's created there. Okay, now it's saying the angle here, which I'm going to label as X, is twice the angle at BCD. Okay, now angle BCD is twice the angle ABC. So BCD would be 2 lots of that, so 2x. And there is a way of doing this without algebra. I think it's a lot easier using algebra, because we need to work out what is remaining. Okay, so we've got already this angle, and this angle that we know about. Okay, so we're going to work out the remaining angle. So remaining angle. Now we know that they add up to 540. And if we take away all the ones we know, so we've got the 125, we've got the 115, and we've got that 90 degrees. Okay, this is a calculator paper, so get my calculator out. So 540 take away 125 plus 115 plus 90, and that gives me 210 left. Okay, so we've got 210 degrees left, and we've got 2x at the bottom and an x on the side. So we know that 3x, okay, I've just added them together, equals the 210. So I get my lines in to solve, and with this we're going to just get rid of that times 3, so we're going to divide 3 both sides, and we've got x equals, and to get my calculator, you should be able to do this in your head because 21 divided by 3 is 7, so therefore this is going to be 70. So x is 70. So it says it wants to work out the angle of the size of the angle at BCD. Now BCD is 2x, so therefore we can just times both sides by 2. There we go. And it gives me the answer of 140 degrees. And our final question comes from OCR. And this is a lot going on in this question, but it does tell us that the first thing we've got to do is work out the size of one interior angle of a regular hexagon. So we can start off with that. So we've learnt that the sum of interior angles, we do n minus 2 times 180. So a hexagon has 6 sides, so it would be 6 minus 2 times 180. And this is calculator paper, so I can just do that on the calculator. 4 times 180, which is 720. But it does say sum of what size of one interior angle. So all we need to do is we need to do 720, which is the sum of all of them, and divide them by 6 because it is regular. It says regular, so they're all the same. So we just divide them by 6. So divide by 6 and we get 120 degrees. And it says show that it's 120, so we know it's right. Okay, so we've got this one here, we've just worked out is 120 degrees. Okay, this one here is obviously it's a square, so it's 90. So we've got to work out what this one here is. Okay, I'm going to do that just by taking away from 360. So we're going to do 360, in fact, size of angle. So we're going to do 360, take away 120 and 90. So on the calculator, 360 take away 120 plus 90 is 150. Now we can use the n-2 formula to then work out how many sides it's got, but that can be a little bit complicated, and there is a little bit of an easier way. If I use this angle here, which we know is 150 now, okay, and if I extend that line down, which I use black just so we've got, there we go. If I extend that line down and work out what's called an exterior angle, okay, so we're looking for the exterior angle, and you'll see why we're doing this in a second if you don't already know. And how we work that out is obviously it's a straight line, so it's 180 take away the interior angle, and that will give us the exterior angle, which will be 30. Now the beautiful thing about exterior angles is they always add up to 360. Every single shape, every single time. So all we need to do to work out the amount of sides it has is we work out how many 30s go into 360. So we're just doing 30 and then we're going to divide it by 360. Wrong way around. We're going to do 360 divided by 30. Didn't look right when I did it. Okay, so again, get my calculator out. You probably do this in your head. 360 divided by 30 equals 12. So there are 12 sides. Now we can check that by using the other formula, sum of interior angles. On the calculator we could do 12 take away 2, which is 10, times 180, and then we can divide that by 12, and it says 150, so we know we've got it right. Well, I hope you enjoyed that video. If you did, please click like. If you want to see more from us, we release videos every single Monday, Tuesday, Wednesday, Thursday, Friday. So click subscribe and click that bell thing to make sure that you have the videos straight to your inbox. If you want to see more from us, we have a website, onmaths.com, which is full of free, completely free resources. Everything on the website is free, and you can even sign up for free to save your scores and join our summer school program. Otherwise, thank you very much, and I'll see you on Monday.